Well, good afternoon, everyone, and welcome to the April 15th, 2025 session in our series on entrepreneurship in Asian high-tech industry. And today, I'm delighted to be able to welcome Dr. Jad Tarifi, who is a co-founder and the CEO of Integral.ai. And Integral.ai is really representing a new stage in the evolution of artificial intelligence, moving toward not only from generative AI to agentive AI and on toward artificial general intelligence, but taking a somewhat different approach that should be more energy efficient and should be maybe faster. So Dr. Tarifi was PhD working on neocortex-inspired artificial intelligence that kind of takes its inspiration from the source of, from the way the brain is structured. And he has also done master's work in quantum computing. He is the author of a 4-volume series of books called Freedom Series. And the first volume in this series has been out since late last year. It's called The Rise of Superintelligence. And it really talks about the future of artificial intelligence and human potential, and also societal transformation in the era of artificial general intelligence, AGI. So the way we'll do things today, I'll ask Dr. Tarifi to give some prepared remarks, and then when he's finished with his prepared remarks, he and I will engage in a fireside chat for about half of the remaining time, and then we'll open it up to audience Q&A. If you're watching on Zoom and you have a question, please put it in the chat window, and we'll make sure that Dr. Tarifi gets your question at the end of when we open things up to the floor. So, Jad, the floor is yours. Thanks for coming.
Thank you for inviting me. I'm happy to be here. I'm going to jump right into the quick presentation because we have too many slides. I'm not going to get through all of them. So just a quick overview, and then I'm excited for the fireside chat. So today we want to talk about moving from agentive AI to AGI. So this is not work that I've done by myself. I did it with my co-founder, who's right here, always supportive. Nima, thank you very much. We've been working together on AI theory and AGI for a very long time. We both did grad school in AI, and then we met at Google. For 9 years, we started the first generative AI team at Google. We also built the first generative models. And we've been at this journey in the new company for the past 4 years. So we're in a very exciting, transformative era. We think this is going to be the most transformative era in human history. And when we look back a few years from now, we'll realize that the world is completely different. And we hopefully will look back in a way that we feel like we've empowered ourselves, and then we've created an era of greater freedom. But right now, in order to unlock this era, we need to solve the current problems of AGI. So if you look at the existing paradigm, which is based on scaling transformers and language models, see two critical challenges. One is inefficiency, and we're talking data compute inefficiency. And this inefficiency is getting worse as we scale these models. And then reliability in terms of hallucination, controllability, the ability to inspect the model, understand what's going on. And that's going to be very important if we actually achieve AGI. So what's our definition of AGI? There's a lot of discussions out there about what AGI is. And broadly, there are 3 types of definitions, but none of them work. Either they're too theoretical, not practical enough, or they tend to be like a game of guacamole where you define it, when you achieve it, and then it's the next thing. So we're defining it in a very clear way. It's an autonomous agent. So AGI is an autonomous agent. It can learn any skill that you define for it, and it has to do so reliably, which means it has to do it without unintended side effects. And second, it has to do so efficiently. And the way we're defining energy efficiency here is energy consumption at or below a human learning the same skill. We think this is a very practical definition of AGI because once we have achieved that, we can broadly scale it and put it as a drop-in replacement for labor. In order to get there, if you think of the current paradigm as black box, we've taken a different technical journey. So starting with the world models and what we call simulators, which make predictions, but also abstract and can grow continually over time. And then moving to these AGI models that can do the efficient planning and take action and update their states autonomously. And the last step is scaling towards super intelligence. And then that is outside the scope of this talk, but it's about giving a higher level objective to the AGI agent and then letting it go out and learn local preferences and scale accordingly. So I'm going to give you a small analogy between AGI and the internet. So the way we manage to scale the internet is through a front end and a back end. So front end would be something like the browser or an app, and the back end is a server. And something similar could happen with AGI. So we think of what we're doing in terms of two fronts. The front end we call Stream, and the back end we call Genesis. So Stream is a universal interface. So the idea is that you want an interface that is there with you all the time, and it's not text, so it's not like an LLM where you're chatting with it all the time because it's a low bandwidth experience. Rather, we want something a lot more multimodal, so vision, language, and all the other senses together mixed, and they're generated on the fly. So our approach to the front end of AGI, it's an interface that's generated dynamically, and then it's customized for you. And it connects to the back end, all the different agents and operators that are doing the actual work. And it's a way for us to merge our stream of consciousness with AGI stream of consciousness. This is a simple example where the keyboard is actually generated on the fly. We can also generate different games. We can generate 3D immersive interactive experiences. And then we can generate entire operating systems where multiple games are being generated at the same time. You can do them in parallel. The backend. The backend is basically where the AGI is actually taking action in the real world. So we call them universal operators. The first thing you need to do if you're taking action in the world is to plan. So we have our model that can actually, given a target state, it can actually plan in an efficient way how to get to that target state. It can do visual planning, it can do language planning, it can do multimodal planning. And then it needs to use tools to actually take physical action in the world. And some tools are already there, but some tools need to be generated. So one example we do here is let the AI design its own tool. So the tool could be an AI, so it could be a code, or it could be a physical robot. In this case, you can talk with the AI, and the AI will actually design a robot for you, and then we'll simulate it across various environments to make sure that it's actually functioning as intended. And then you can use 3D printers to actually assemble and source different parts, and then assemble them together to actually get the robot that is custom made on demand. Of course, you need to do testing before you deploy. You also need to teach the AI different skills. So one way to teach the model is to actually give it demonstrations. Another is to actually use the interface so that the AI pre-analyzes what are the potential things you might want to ask for, and then kind of you select in a very intuitive way what you need. But the most important thing is for the AI to teach itself. So it has to go out and actually intelligently based on what it thinks you want, and then learn the skill on the fly. So there are some of the skills we've learned. These are hard to actually do reliably, even though they look simple, like liquid pouring, powder scooping, manipulating wires, because the physics is not easy to model. And you can do things like cutting. I'll show you like a couple of cute demos. So this is in our office in Tokyo, where you can order coffee and the robot will make a plan. And then based on the plan, it will go step by step in order to actually do the order for you. One more is teppanyaki. Since we're in Japan, we like to embrace the culture. So you can order steak, mushrooms, vegetables, wine, juice, and it's going to be able to make the plan. And then you decide how you like your food to be cooked. And it's going to execute all of it end to end.
Jad, can I ask you a question?
Yes.
When you were developing this, so this is something that Integral.ai does, right? You've got basically somebody prompts you, tells you what they want the robot to do, and the system designs the robot for them.
Yep.
How much back and forth had to happen before you could get a robot that does teppanyaki?
The teppanyaki thing is 2 years and 4-month-old.
Okay,
So
that was done back then, yeah.
Yeah, we did it in a private event in Tokyo, January 2023. It was very messy. The first iteration, you know, one of the reasons we don't have teppanyaki in our office now is we burned a lot of oil on the way. So now we have a coffee. Coffee oil is much safer, much more reliable. So a lot of back and forth. We got to the prototype fairly quickly, within a month. But then it took about 5 months to get it reliable enough so it can cook 40 steaks in one day nonstop.
Okay. And the same system will design robots that do the other things that you showed on that slide.
So this is pre our latest, right? So with our latest models, yes. So the whole idea is that you design everything end to end, from idea to actual new robot body.
Now, I haven't seen your slides yet, but you're also thinking about using the AI system to design other things like games.
Yes, and I showed an example of that with the
Right.
Then.
Okay.
Sounds you're excited for the fireside chat.
Okay.
Let me finish quickly, yeah. Sure. I have one more slide because we got there already. So I just want to say that it's not just about the technology. There's a lot of things there, especially when you want to have open-ended AGI and superintelligence. So we need to think about what's the meta objective that we need to give this system. We need to think about the economic implications, radical automation, and things like meaning and purpose for what we do after we have superintelligence. And we've been thinking about this for a very long time. So we've explored this in the book that you kindly mentioned. So we can start the fireside.
What is the scope of your exhaustiveness? Like, you can't do everything, right? So what's the scoping? Like, what's the maximum you can do with this?
Where are you now? Or in terms of breadth of different kind of tasks?
We can't do everything. Nobody told me.
So I can do everything.
The whole point of AGI is to have a safety model that is general, that can learn any skill. Right. So the scope of what we do is build that capability, right? And then the model can learn any skill. And by any skill means everything that is learnable.
Yeah, so we obviously have questions from the audience that are kind of taking precedence. Go ahead.
It's sort of the same question as he had. I have a friend who's a cardiologist at UCSF, and he said the world is becoming so complicated that in the future maybe the future's now, we'll need a doctor for the big toe on your left foot and the big toe on your right foot. And of course, which means that human beings, where they're thinking and where we fit into our roles for solving problems, we have to become specialists. Of course, human beings are separated by our bodies. We can't squeeze two brains together and make them a jack of all trades, a Renaissance person, for example. But when we get to software, can we combine brains, or is it better to have them separate?
Yeah, this is a great question that was confusing to a lot of people when generative AI started. When we started working in generative AI, the biggest criticism was exactly this. People said we need specialized AI system, can do one thing and do one thing only, and can do it better than other things, and that's the thing that will actually be successful in sell. And our argument was the opposite. intelligence, a lot of the insight comes from the lateral connections that you make across fields. And this is the argument that actually won out. So in reality, right now, if you want to build a system to do sentiment analysis on Twitter tweets, or you want to do analysis of articles for trading, you don't use a specialized system anymore. You use the broad-based, pre-trained LLM. So what we've seen is that these, when you generalize horizontally, you do better, which is unintuitive, but it's a fact. And there's a good reason for that. And the reason is that when you're trying to learn a skill, that you can get away with learning 80% pretty quickly, but the remaining 20% things that are surprising that you haven't seen in your training data, unexpected. And where are you going to see them? You're going to see them if you focus on other things too, right? So if you're learning to drive a car, but you also somehow learn about circuses. So if you see like a clown walking on the street, oh, you recognize, I know what that is.
So, Dad, there's a lot of directions that I want to cover in our session today. And I think the first one is you've taken what is really sort of very much leading edge approach to AI. And you've decided to go down this path using a startup company. And I get the sense that you're not freezing the level of AI. You're letting the AI continue to learn and grow as the company is learning and growing. Why do this in a startup company instead of doing it in a university or in a research institute or in a big company lab?
That's a question. So I initially didn't want to start a company. Nima and I talked about it. Nima had just got his company acquired by Google. And we thought the best way to advance AI is to start a team at Google. Unfortunately, I got privileged to be able to get all the funding and resources I needed at Google to do that. And that's how the first generative AI team got started. But what I found is that you need
And we're talking maybe 6 years ago?
No, we're talking 12 years ago.
12 years ago, okay.
2013.
Yeah.
So what we found is that when the technology is moving really, really fast, you also want to be able to make a lot of executive decisions of how you want to actually iterate on this technology, not only on the technical side, but also in terms of interacting with potential users, potential partners, and generally the vision of what you want to achieve with that story. So a startup is a great vehicle to let you iterate and move fast. And whenever you have a big platform change, a big fundamental technologies change, startups win because they can make these decisions faster. And when you do that enough times, there's a compounding effect where you can create much bigger impact than you can do otherwise. And we've seen this over and over in the history of technology, most recently with Google versus OpenAI.
Okay. So having decided to use the startup route, why are you in Tokyo?
This is a good question. So it felt early on when we were trying to do this company that LLMs and digital world is well taken care of. We didn't feel worried about that. We felt that where the biggest potential impact for something new going to be is in the real world.
Yeah.
So bringing AI to the real world is very important. Now, I looked around in the Bay Area, and I'm a strong believer in working with early partners to see what they need, what's their pain point. And what we found is that there's not much of a robotics industry. Turns out that we outsource manufacturing, as now is very famous. But back in 2017, I was looking around, where is the Silicon Valley for robotics?
Okay.
And the clear answer was Tokyo. So Tokyo, around back then, was about 50% of the world's industrial robot production. So Japan, a small country, is as big as the rest of the world combined. So we thought it's going to be very special if we can bring the best point of Silicon Valley, which is us, the AI side, and then the best point of Japan, which is robotics, the deep industrial base. If you think about even the iPhone, most of the interesting parts are actually built in Japan.
Okay. So you and Nima are not Japanese. So is it difficult to work in the Japanese environment? I got to ask you this question. We'll get back to the AI. What kind of, challenges do you have in getting labor, getting people to work for the company, or talking to customers, that kind of thing? How do you overcome that?
I think being open-minded and curious is a superpower, and it can let you overcome any barrier. So for me, I was just really curious about people, understanding the culture and how to engage with them. I learned Japanese in the process. I'm not great, but I'm good enough to have a small conversation. What I found is that doing business in Japan is actually very exciting in a complementary way to the Bay Area. They're less fast than we are, but they're steady. And so once you build a relationship based on trust and character understanding, then this relationship is reliable and you can count on it. It's trustworthy. And there's a lot of integrity in their work culture.
Yeah.
And in terms of building a team, the team works very well together. There's no drama. People are very supportive of each other. They love mentoring each other. Basically, you can count on investing in these people as long-term partners and company members. And I think that's a very important thing that we don't have as much here.
Yeah.
Although there are downsides, right? So I'm not trying to paint like, oh, this is all part of the
this is really interesting. In some ways, you're one of the first truly borderless companies from the very beginning. You're there close to your market, and you're looking at really industry across the world as people who will work with you. I think that this is kind of an inspiring sort of thing to point out in the middle of the sort of movement away from globalism that you see in the world. Back to what you're doing with AI. So neocortex inspired AI. You made the point that the current LLMs based on transformer are really inefficient. And we see this in the amount of energy that they use. We see this in the amount of money that it takes to develop a model. What are the biggest differences between what you're doing and what the traditional LLM world is doing?
Great. With LLM, the way I think about it is it's a black box that's trying to do brute force the function you give it. So the advantage of that is that you don't have to think too much about how the thing works on the inside, right? So you can just give it a lot of energy, a lot of data, and it's gonna brute force everything. And we have a lot of computational reasons, there are theoretical reasons to believe why it will work, and it does. But that doesn't satisfy the criteria for AGI that we're presenting, because we want something that's actually useful and can be trained over time and grows over time. And to get there, we drew on inspiration from the neocortex. If you look at the neocortex,
This is the outer surfaces of the brain.
Yes, so it's the big fatty thing. If you take it out of someone's head and you unravel it, it turns out to be like sheet of paper. It's two-dimensional, it's not three-dimensional. And the reason it looks three-dimensional is that it wrinkles on itself in order to fit in the skull, because it's grown too big for our size. And if you look at that sheet of paper, it looks very self-similar. It's not exactly self-similar, but it's very self-similar. And if you somehow remove the visual input and put it in the auditory input, and remove the sense of taste and you put it in a sense of sight, it will work. It will take some time to adapt, but it will work. So it seems like there's a common cortical algorithm or a certain algorithmic insight that's being repeated over and over in the neocortex. This is from so many different, not only anatomical, but also behavioral. Like people have actually put a camera on someone's head and connected it to someone's tongue, and they could see. So we wanted to kind of understand the algorithms for that. That's what I did my PhD on, and then we think we got there. in terms of unlocking the a lot of trial and error, but we found actually the key insights. What turns out is that the neocortex has a way of processing the data that is not brute force, that is mirroring the structure of the complex world that we live in, which is hierarchical. It's not densely connected. There are some disjoint hierarchical subsets that you can create. And then because of that, it can learn a lot more efficiently in terms of data and compute. And also it can do continuous learning, which is something we've done as well.
So do you think there will be another major transformation between this kind of medium stage before you get to true AGI? Or is this the approach that will go all the way to AGI?
The neocortex one?
Yeah.
Yes, I think this is AGI.
Okay. So you're navigating a very, I think, challenging path. On the kind of social side, there's all the people who are terrified of AGI and trying to say you should not allow it to be developed, right? Saying that this will, we're going to create things that destroy human beings. And at the same time, you've got to grow this as a business and become as much, using your revenue, not just tens of dollars of investment, in order to be successful as a business as you're going along. How do you navigate the path?
Yeah, I think we've thought way more than I think most companies out there on the social implications, because we've been working on this for me at least 20 years. And the book is one of the results of that. But I think we have a pretty good story of how we can actually create something that's sustainable from a business perspective, but also socially constructive. And we have to also lead in terms of thought leadership and bring the story out there for people. And that's why I'm here. So doing a lot of tool recently. In terms of the business model, I think it's pretty simple. If you assume AGI will be everywhere, it's going to be as ubiquitous as electricity, right? So all you need to do is offer it in the cheapest way possible. And then whenever you use AGI, you have to use compute. And compute has the cost by the economy. And so if you're charging a very small margin on the compute, I think that's enough to power a company to be a hyperscaler.
I mean, that tends to be the model that the giants have been using. We want to be the platform, and everybody will use our platform. And we can afford to lower our margin to do that. But as a startup company, that's tough.
Yes. So what you need to do is have early believers. And thankfully, because we focus on the real world, there's a lot of big companies are interested. So we think about Toyota, Honda, all the big enterprises that want to bring robotics to the factory or service industries. And so we collaborate with them. Usually that involves a lot of upfront costs that we can use to fund our scale.
Okay.
And then as it goes to deployment, we transition to this more scalable model that we mentioned.
Okay. As you grow, you can scale like that. Yeah, that makes good sense. So we can open the floor to some audience questions at this point. I may have a few questions myself. There's some questions coming in on chat while you're thinking. Go ahead.
Back to some of the earlier questions on running a business in Tokyo. I had two questions around that. The first one is, a lot of the discourse I've heard is that recruiting is notoriously really difficult for foreign founders who are looking for talent within Tokyo. So I'm curious as how you were able to navigate recruiting in that space. And then the second one is, how do you conduct business in Japan while still staying close with Silicon Valley and making sure that there is a relationship and dynamic there?
In terms of recruiting, we've been extremely successful, I would say. We have generations of Japan robot champions, including the team captain of Japan team that won the World Robotics Championship. We have several people that graduated #1 in the University of Tokyo. Actually, most of our company members are University of Tokyo, and they all recruit each other. So what I found is that you really want to find these key superstars, and then they're famous. Like one of our engineers, he goes on the TV and he judges, younger engineers on their technical work, and everybody wants to go wherever he goes. Right? So pick some key star players, and then we've never used a recruiter. We don't have a plan to use a recruiter. We already have way too many people that want to join that we can afford.
Can I ask what happens when you tell somebody that, oh, by the way, we're based in Tokyo?
They love it. So I think nerds, or we call otaku people, they love Japan because it's peaceful, it's friendly for introverts. There's a lot of things to do. Buddhist, you heard of that? And a lot of people are even willing to take a significant salary decrease, like 50% salary decrease to move to Japan. So it's a very competitive, it's a competitive advantage if you're able to do that. However, you need to break into the culture. And I would say I've met a lot of entrepreneurs that are a little bit arrogant. They think they go to Japan and they want to tell them how to run companies. That's not going to work. So you have to come at it from a very respectful, compassionate place and kind of understand the way the culture works, not try to like overpower it. And I think beautiful things can happen.
You know, it occurs to me that we didn't give the basic facts about Integral.ai. The company was founded in 2021. And where are you on your stage, on your progress?
There is this like a huge valley between seed and Series A. We're somewhere in that valley.
Okay, especially in this kind of an area where you're really at the leading edge of the technology. From here, from one of the questions that has come in on Zoom, really has to do with what kind of metrics you can use to measure your progress toward AGI. There was a specific point that was mentioned in the question about a prize, the AGI prize.
Yeah, the ARC prize is an interesting metric, and we don't follow that because we think it's hackable. And the ARC one was won by OpenAI model, even though it's not technically one because they used more resources than permitted. But we don't really think this is the best metric. The metric that I gave is you want to have a user adversarially define a new task, so an unseen task. And then you want to see the AI model autonomously teach itself that task. And then no unintended side effects. So if it's trying to learn to cook steak, it kind of burn the kitchen in the process to do so. And then you measure the total energy, and it's small. It's about a human or less. That is AGI. I don't need a metric. That is, to me, if you have that.
If you use the definition of autonomously learning new skills, that makes very good sense. And that's easy to look at kind of in an objective way.
Reliably and efficiently.
Yeah. What can you say about the way your neocortex inspired model is structured? And, do you plan to make it an open model that you will have, or do you think that this will be proprietary model?
Yeah, so for us, we don't need to worry too much about opening the technology in the future because the models continuously learn over time. So one of the reasons there's a trade-off right now between closed and open source is that you need to put a lot of upfront cost to pre-train the model. And then what are you going to do with it? Are you going to give it away, or are you going to keep it? But in our case, the model is constantly growing every day. That means that we could afford to do both. We could afford to say, hey, here's an open source version of the model from 1 year ago. But if you want to get the latest and greatest, then you need to pay that small premium on top of the compute. And anyway, you're gonna pay the compute to run it.
Yeah.
So it seems to me like a good way to earn trust by making people realize that the technology is, we're not putting anything secret in the model,
Yeah.
but at the same time gives you a very reliable, defensible business model.
Okay, that sounds good. Well, you're next. I think you-
When I'm guessing, and let me see if I understand correctly, you're developing the model on some large computer system and then creating a robot for, say, a car company. You will then have that robot have local intelligence. You don't need to go back to some gigantic server every time. It's kind of at the edge, I'm expecting. But does this robot keep on learning? Is it really a general purpose robot that could be moved around? Or is the learning, the continuous learning that you described, happening back home?
Yeah, good question. So you can actually have, the model doesn't have to be huge, right? You can have the model run locally and then, but what our preferred model is to have, the model run locally, learn the local skill, but also in a privacy preserving way, syndicate back with a larger model. So that benefit is broadly shared for other customers. So the way there's a small business question there, which is like, are we going to offer everyone the ability to continuously learn? And then if they continuously learn, do they have to feed the main model, or are they allowed to? And the answer is simple. If you want to have your own private thing that you don't update the publicly accessible model, fine, but you just have to pay extra for it.
Go ahead.
Hi, thank you for the sharing. And I have two questions here. The first is, what is your business model? How can you financially support yourself? I think you mentioned you are from the seed to A. It may feel like you still need to burn a lot of capital. How can you financially support yourself? The number two question is, what's the challenging as a foreigner to start the business in a foreign country? And what is your takeaway from that?
Thank you. So the business model, so we have the long-term business we mentioned. The shorter term one is to actually offer this model to enterprises because they can afford to pay extra in order, because it's kind of like they want it in deployment, but before that, they need to prove that it works internally. They need to do a lot of R&D. They need a lot of consulting support. So by having these few high-touch customers, which can afford it, we can actually generate some revenue to keep us afloat. And of course, thanks to the investment community, we can, keep the projections going and then transition to a more scalable model. Does that make sense?
So right now you are still burning the capital.
Oh yeah. We're planning to burn the capital like for a very long time.
Well, and actually that means you're growing, right? The reason to burn capital is that you are increasing revenue, but you're burning the capital at a rate that will let you exponentially achieve revenue.
I want to comment on that because when I started this company in the beginning, I was a little uncomfortable to burn capital. I was thinking, we have to get to equal very soon. And then because of that, we generated $1.2 million in revenue very, very quickly. But then I realized that's such a waste of time because every time you get a new customer, they have their own, you have to honor them, right? So you have to do your best. And because of that, you have to personalize a lot of your technology to them, and that might slow you down. So to me, I grew out of it where I was, okay, I really want to maximize shareholder value or change the world, however you want to look at it, it's better to burn capital and move faster. And that's the reason to be a startup in the first place. Right?
Thank you. I saw.
The second question.
Yeah.
Oh, go ahead.
I have question two is just what's the challenging as a foreigner founder to start up a company in a foreign country? Yeah. And what's the takeaway that we can share?
So everything is harder. Like, for example, it took 3 months to open a bank account in Japan. 3 months. And it's not like we were lazy. We were really aggressively pursuing it every week, and it took 3 months. You have to understand the cultural nuances, and you also have to introduce yourself a lot. You have to be extrovert in the sense that, I would go to these big industrial show and just go around and introduce myself to everyone.
Yeah.
And if you don't like doing that, I guess it's going to be very hard. To me, I want to balance that though, because I think the advantages are so significant as well, because people are curious about you. Like the most frequent question I get in Japan is, why did you come here? Like you were in Silicon Valley, why would you choose to come? And so people are curious, which opens doors. And then you have an advantage because you can think in a different cultural mindset, but you also have a beginner's mindset in the new culture. So you can see opportunities where other people can't. So it's challenges, but I feel like if with the right attitude, it can turn into advantages.
You're not doing it because it's easy. Go ahead.
Thank you for sharing your knowledge, and Amrushal. So I have a question that what I feel as summarize what integral AI does is, so integral AI is taking all of the humanity from the normal paradigm that we have to an AGI paradigm, right? But it feels like it's like a whole ecosystem. It's like building an internet, right? So someone has to probably write a browser, someone has to probably create an app. So it's like a whole ecosystem. So do you feel that there are some gaps right now which can be filled by different companies, other parties apart from your company, and then they will sort of support into the vision that you guys have? So what are those gaps? What are those 2-3 topmost opportunities where you see that, okay, we are building this is our vision, but then some other things can be built by someone else, and maybe what are those gaps? What are those opportunities?
Yeah. Are you sure I'm only allowed to say 2 or 3 or?
It's up to you. It's up to you. I just like a.
Yeah, there's a lot of opportunities, right? So that's why we think of our primary customer is developers, because as you said, we're building an entire ecosystem, and you can think of it at multiple levels. There are going to be people who are needed to create content, right? Because if the browser of the future is something that is generated dynamically, most people don't want to generate their own thing. They want content. There's a lot of people that are needed on the compute side in terms of infrastructure for compute. The new models have different compute characteristics than existing models because they're continuously trained. A lot of things to be done on the edge. In terms of robotics, wow, there's like 100 companies I can think of there. Then you've got the digital transformation people. So people who go to existing businesses and say, hey, I can help you do this better by using this new technology. But they need someone to actually handhold them and help them in this.
Let me ask a question from Zoom first. How far away are we from the situation in which the AI system enabled robot will just observe the situation around it and autonomously decide what it needs to do?
Without revealing any secret. We're not very far at all.
Okay. So in that case, the verbal prompt, the text prompt may gradually go away.
Yes, so to do that, well, we need, we call it open-ended intelligence.
Yeah.
So the model has to kind of figure out what it wants on its own.
Yeah.
By observing its environment, ideally having compassion. So it can kind of figure out what you want and try to help you. And actually, we just wrote a paper about this, Nima and I.
Okay.
And just a thought leadership paper to explain what we're already building.
So the continuing role for the human is to want something to happen.
Yes.
That's the human desire. I want to have this thing make a cup of coffee for me. So I want this, I want something to be done. And really in the real world, in the business world, robots have to be modified all the time. Anytime there's a kind of a major change in the shape of a component that's going to go, for instance, into an automobile, a lot of what they do can be the end of the robot arm, the machine tool. But you really have to change the way the robot moves, and you have to have a lot of modifications going on to factory robots all the time. So that is a big market.
To upgrade robots.
Yeah. Well, or to continually modify the factory for the most effective and efficient way of making the product it's trying to make.
Yep.
Yeah. Is that, or am I kind of in a different direction from where you're interested in going?
I think having flexible factories is very important. And actually, factories are a lot more flexible now than I thought they were.
Yeah.
I've seen factories that build like 1,000 products, just one factory, and they reconfigure it whenever they want to build. So the future is like basically a factory that can build anything.
Yeah. Right. Okay, we're getting lots of questions. I think I saw your hand first.
So I'd like to learn more about you said the robots can do their own pretty soon, and Trump probably go away pretty soon. But then how human can communicate with the worker to set goals for it? Is that like, for example, if the robots can figure out what I want, can it actually align with my personal interests? And also if my personal interest is changing over time, and also if we train a bigger model, generalized, how we can make sure it align with not a certain group of people, but like more general value, or people with different value, how we can align with that as well. What do you envision on this area?
Right. So let's start with the interface. So you communicating with the robot, you can communicate in any way you like. You can communicate with your voice. You can communicate with your body language. You can just sit there and look hungry, and the robot should look at you and be like, "Oh, it looks hungry." And so that's the function of empathy, right? When you have a friend look at you that knows you very well, they should be able to assess the situation very quickly. They might not know everything, so they might have to have a conversation. They might want to ask, like, "Are you really hungry, or are you just a little sad today?" And then you'll be able to express. And then in terms of teaching a skill, you can also sometimes show. Like, for example, you want to teach a robot how to make your favorite salad. Maybe the way you cut tomato is a little bit different. You like a small or like a really big one. It's actually showing it. So our interface, we call it sometimes show and tell. That's at the level of the interface. But then the idea is that the robot should be self-motivated to have the curiosity to learn about you and support your needs if your needs are aligned with the global objective. So how to make sure this global objective is open? The global objective that we come to believe is the right one is what we call collective agency. So the ultimate goal, the meta goal that the AI is seeking is to maximize collective agency. And that is an under constrained objective in the sense that this is an objective that doesn't specify all the details. It has to look at the world and then fill in the details. But it helps if there are conflicting demands or there are conflicting goals. Then it can arbitrate upon them by that idea, the meta goal of maximizing collective agency, which another word for it is freedom.
But how you define, like how we let those robots know those general global objective? For example, I think from a lot of sci-fi movies, we saw that we set a goal to say the robots should serve the people, but there's a bad side effect that's generated by optimizing that goal. They, for example, some robots just like trap all the humans to keep them safe, but that's not what humans do. Like what? Like how we figure out that?
Yeah, so if you carefully define what collective agency means, by actually understanding what agency means. So agency itself can be composed into four dimensions. There's perception or knowledge, and there's planning or benevolence, and there's skills or power, and there's renewal or vitality. So there's this cycle that an agent needs to take in order for it to exist in the world. Any agent needs to have that cycle. So our model simply tries to maximize that collective agency. And you can specify it in several ways. You can specify it with language, and you can specify it actually in a computational way. But once you have that high level objective is just there to give you the open-endedness, but then compassion is when that open-endedness meets a specific goal. So it's not that high level objective is not enough without a detailed goal that the user has to give. Does that make sense?
So in the world of Silicon Valley, people are always comparing different approaches to things, right? So we have a question from Zoom about the company Singularity Net that is by Ben Goertzer. Do you know?
I know that for a long time.
Okay, so what distinguishes your approach from theirs?
So I haven't met Ben, I haven't seen Ben in 20 years, so.
Well, the question, because the question gives a kind of long description.
But I'm
Okay,
I'm kind of familiar with what he's doing.
yeah, okay.
I can tell you, but I don't know the details because Ben is creative, and so he's always changing.
So he's always growing, yeah. Okay.
But my current understanding is that what Ben is pursuing is a hybrid architecture where you're taking something like a transformer or a deep network and a symbolic system, and then mixing them together. Is the approach he's taking. We don't think that you need any symbolic stuff actually. So we think you can do the whole thing with new architectures within deep.
Okay,
And we think the symbolic thing is very attractive in the beginning because it gives you the illusion that you're understanding what's going on, and smart people like symbolic system because they can use algorithms. Unfortunately, I think it becomes a bottleneck because it limits the flexibility of your.
so one of the things that indicates is moving way beyond input that is kind of in terms of language, right? I mean, the whole difference between a language model and a foundation. Are you really seeing efficient processing of images and audio input and everything else? That is core parts of the model now.
Yes, I mean, that's when it matters.
Yeah.
If the world was purely based on language, I feel like we already have AGI with transformers. We don't really need that much difference. You probably want to do some quick here and there. But where the rubber meets the road, where it really gets to the limitation is when you actually move to the real world, when you have action, when you have actual visual stream, video, and maybe even video output. That is when these models hit their.
Okay, I saw a question from. Oh, go ahead.
I had a question about, I just envision these robots, these learning robots, right? And you have some of them that are learning on their own in a factory somewhere based on the business model I described earlier, and some of them are feeding back into the model. How do you plan to manage ownership of intellectual property as a business?
You mean intellectual property for the skills?
Well, yeah, so I, if you have a robot working in a factory and it's continuously learning, and then there's a new process getting developed as a result of something discovered. Maybe they're feeding into the model, maybe they're not feeding into your general model, or maybe they're, maybe they paid for the full price to have full ownership of that. But how are you planning to manage that?
So I'll give you the business answer, and then I'll give you the controversial answer. So let's start with.
I'll take them both, sure, yeah.
The business answer is if you want the free version of the model where you're just basically paying for electricity, then we expect you to, whatever skills that's learned with your data is shared publicly. Everybody, it's a common thing. If you want to keep the skills private to you, then you'd have to pay extra, and then that's fine. Then, your model doesn't update the global model, and then there's no intellectual property. This is the business answer. So if you want to keep your intellectual property, just pay extra. And if you have something basically almost free, then you want to contribute back to the rest of the world. Just like you're benefiting from the training from other companies. If you want the more controversial answer, which is what I truly believe, I think intellectual property is dead. I think the next, maybe, most people haven't realized it's dead, but within the next few years, we're not going to be talking about intellectual property simply because we have super intelligence. So what's the reason intellectual property exists is that he's working very hard in a lab for 10 years, and I want to protect the investment that he has in his time. But when we have super intelligence, that intellectual property is just, it loses its value. It becomes more of an adversarial thing that I think has no social value, but can actually be destructive. I would say bye-bye to intellectual property.
Okay,
Controversial, right?
Yeah, absolutely.
so how do we understand what superintelligence is?
Great. So we have a clear definition of superintelligence.
Okay.
So the way we define superintelligence is superintelligence in collaboration with a group of humans of any size, 1 people, 10 people, humanity, is not more competent than superintelligence alone. So I'll give you an example with chess. Or with chess, when the earliest model, when Deep Blue beat Kasparov, right?
Yeah.
For a few months after that, an AI plus a human could beat an AI. But now an AI just holds back, a human just holds the AI back. So human plus AI do not beat an AI alone. And to me, that is the definition of superintelligence for chess. So to me, superintelligence is an asymptotic definition. For any given skill, whenever that skill can be done more competently by AI alone than with involving humans in the loop, that's where we say we've achieved superintelligence in that domain.
Okay, thank you. Other questions from here? Go ahead, Ed.
Can you give us an insight into what professions or disciplines do you think will be impacted by this? So I'm thinking of structural engineering, architecture, medicine, computer-aided design. One thought for medicine, when IBM released Watson, they initially pitched it as the physician's desk replacement.
Yeah. So if you take the longer view, I think all work should be obsolete. I think all of the professions should be obsolete. But if you take the longer view. Now, how it's going to play out is that there's a lot of structural constraint in our system that, for example, in order to prescribe medicine, you need to have a license, right? In order to do something that can potentially deprive freedom from people, you need to be a judge. So there are these kind of social and legal hurdles that I think will take a long time to process through. But personally, I don't see anything that's immune to automation in terms of work.
How about attorneys?
Okay.
How about attorneys?
I feel like attorneys are pretty easy to automate, but
Let's do. But they'll make that illegal.
Exactly. So unless you have some structural issues preventing this, I think the automation should.
Although I have to comment on this, we had the chief legal counsel for Synopsys years ago spoken in this series. And he said the reason engineers hate lawyers is because the outcome of what you propose or what you argue in a law court is indeterminate. And in engineering, if you don't get the outcome that's expected from the laws of physics, something is wrong. You've got to fix your machine, right? Or you can fix your machine. So you do have this whole kind of question of indeterminacy and ambiguity that is a big part of the human experience.
LLMs are really good at that.
Okay. Got a couple of Japan questions. And one person was asking, do you think that with AI, it will not be important to learn a foreign language like Japanese, no matter where you are?
It depends on what the purpose is for learning the language. If the purpose is to communicate, it will become less and less important. But still, even now, there's some friction. Personally, I think the reason to learn the language is to understand the culture more deeply and to learn to think in a different way. So when I speak Arabic or when I speak Japanese, I feel like a different part of my brain is working, and I have access to a different form of intelligence that's acquired from the social understanding of that environment.
It opens the door, yeah, the other language. The other Japan question is really about how you fit into the kind of startup ecosystem in Japan, in Tokyo now. I mean, there are quite a few advanced technology companies in the startup sector in Japan, but you see yourselves as really sticking out. People kind of look at you like, these are different.
I'd like to think so, but we'd have to ask them. In Japan, I think the AI companies all know each other. There's a handful, and there are a series of events where we meet and we tell our stories and stuff like that. I would say we stand up, but we try not to stand up too much. We actually try to under ourselves.
And do the big company AI labs like Fujitsu and these groups, do you wind up running into them at these events, or do they kind of keep to themselves?
No, these events are mostly for startups.
Okay,
Mostly startups. I mean, yeah.
Okay. I saw a hand back here in that corner. Go ahead.
Hi, I work on medical devices. So one of the major requirements is safety comes first, even before they move. And the safety part is generally addressed by a different team. How would you propose if you start handling more and more critical systems? I just want ideas on how you go about doing, and you can't trust the person who's doing it to actually following the laws of safety. Okay, so you want some independent agency to do that safety. So you have a robot doing surgery, for example, and you need independent verification and independent controls. Some ideas would help over there.
I agree that you need some type of certification if you want to replace a doctor. I talked to Intuitive Surgical about this a while back, and the plan that I felt that they want to do, I can't be sure, but when I tried to push for AI surgeon, basically you want to start with simulators, right? And just do simulation of a surgery, then do simulated surgery. Then you can move to being a surgeon coach. The doctor is doing the everything, but then the AI is just coaching them. At some point, the coach is so good, and the bottleneck is the surgeon, and the case becomes very clear.
I saw your hand. I saw your hand, right?
Yeah. I was just curious with your current technology, your current model. Could you present a robot that could read a room and do a stand-up comedy? Is that something that you can do already? Is that difficult?
Stand-up comedy part is so easy.
Is that easy? Okay.
Yeah, the walking around in the room is the hard part. Stand-up comedy, ChatGPT can already do something like that, right?
Go ahead.
Yeah, I don't think I realized what was your reason for moving to Japan. But number two is, how do you measure the accuracy? Because now you're having multiple skills, and the accuracy is some of these skills. And at what accuracy level do you think this is acceptable? Of course, it will depend on the context, like safety and other things, but how do you fundamentally measure accuracy of an AGI system?
Yeah, so the traditional measure of accuracy is a surprise. So how many unintended experiences that you're encountering, right? So as long as you're not surprised, everything is going as predicted, you should be very accurate. And that's exactly how the brain.
Because when the brain makes unintended errors and other things, so it's not acceptable. I don't think I can expect AGI to be 100% accurate.
No, yeah, you cannot. And that's why we don't find that defining AGI by accuracy to be that fruitful. Or like ARC or any benchmark like this, it's the ability to overcome or increase the accuracy that learning is. Simply like there's the idea called Turing completeness, right? So pretty much any computer, I could give it enough energy, data, it can brute force anything. So you can get arbitrary accuracy quite easily. But that's not the interest. The interesting part is to be able to flexibly increase the accuracy without unintended consequences and with.
Why Japan?
Yeah, so Silicon Valley, Tokyo is Silicon Valley for robotics. Oh. And more generally Asia.
In your estimate, where do you think the competition is in USA, Japan, and China?
USA, Japan, and China. So Japan is, it's not a major player. I'm assuming you're talking about AI or robotics. Okay.
AGI, your study.
I would say besides us, Japan is not a major player with AI. The US is leading, and I wouldn't underestimate that. There's a lot of momentum, and these models are improving in an accelerated way. And China and the UK are number 2.
You still think US is number 1?
Yeah, for sure.
Thank you. Go ahead.
So when do you see a general purpose robo at home doing all the household chores?
Next year.
Arbitrary household chores.
What are the main constraints to get there between here and that kind of general purpose service robot?
Assuming you have an AGI capable model, which we're going to assume
right.
for the time being, then it's just about scaling that pre-training of the model on a lot of V2 data, and that's it. There's this coffee test where, like, you have AGI for robotics if a robot can go to a new house it hasn't seen before, go in your house and then make coffee for you. Would you be satisfied with the coffee test?
And of course, robotics itself on the physical side is developing quickly with, soft grip and other kinds of aspects of the mechanics.
So I want to push back on that a little bit.
Okay.
I think robotics on the physical side is solved like more than 10 years ago.
Okay.
It's always been a software issue. It's always been an intelligence issue because robots are already actually too engineered. They're too accurate. They're. I actually prefer if we make the robots, the physical body, less precise, less strong, because our body is not that precise and strong. And then make it much cheaper as a result. I feel like that's a good outcome.
So that is the flexibility you were talking about earlier. Yeah. Okay. Other questions? Go ahead.
I'm just following up on that point about how the actual hardware side of it is more commodified now, like the learning curve, we're already kind of plateauing. I was wondering if you could kind of connect that to your reasoning to move to Japan. Like, do you think Japan's hardware edge in robotics is enduring? If robotics, but the improvement in robotics or the intellectual challenge of the hardware side is kind of stuck.
Yeah, so it's in the long term, there's no advantage to anything, right? More on the short term, until we get, we want to start with people who are using robots in their business today, people who have the expertise to build these different motor junctions, these different axles, all these different robot parts are actually existing right now. Now, 5 years from now, I hope the world will be so changed that there wouldn't be a local advantage to any country. But on the short term, yes, I see that.
Okay. So we're moving toward the end of the session, and we have some refreshments outside for everybody who is here in person. Unfortunately, on Zoom, you don't get anything. But kind of last question, if we have a return engagement, you come back and speak for us 10 years from now, what will we be talking about?
I think in 10 years, we should be talking about. Can I give a 5-year answer?
Okay, fine. We'll go for 5.
In 5 years, we should be talking
I
whether
only have a 3-year contract anyway.
3 years. I think we should be talking about whether we want to live 1,000 years or 10,000 years. And since we're all going to
we
be
didn't
fabulously
really talk
rich.
about the societal impact of this.
Yeah.
So if the AGI, if the superintelligence is in the machine, what are the normal human intelligence people going to be doing?
So in the book, I define the role of humanity as a guiding force. So the meaning makers.
Yeah.
So when you have if any of you have a child, I don't have a child, but my friends who do tell me that they find that their child gives them more meaning to their life than their own goals. And I would say, in that sense, we would be giving the meaning to superintelligence. Superintelligence is there to.
Okay, so then now let's jump ahead for the 5 years. How far along that? Will we have a bunch of teenage robots?
I think it's more like we're the teenagers. We're the teenagers. But I would say, yeah, living, arguing whether humans should live 1,000 or 10,000 years, and then I would hope that a lot of the we're talking about. We've passed the idea of basic income and talking about universal prosperity and dealing with the social implications. In terms that's on the social side, and then in terms of the technology side, I think we wouldn't have full robot at scale at that point in 5 years because the physical world has a certain speed to it.
Yeah.
So we will be talking about what we call super factories, which are basically just like you order something from Amazon, within one click, you have a custom robot made for you, already with all the intelligence, and does the task. And then we're talking about, very soon, and on the news, people are very soon. There's going to be many more robots than humans, and some people will say, let's kill the robot.
Yeah,
I hope that
I hope we don't have that. Yes. John, thank you so much for giving us a really kind of window into a really new area of the future. And, this is a little different to what we usually have in this series. Usually you get a lot of stuff about what the venture capital system is like in the country and what the, how entrepreneurs look at exits and so forth in the country. This is refreshing because this is really looking at the future and honoring, respecting the location, taking a good advantage of the location, but doing something that really is changing the world. So very much for a great